Hello, and welcome to another Tech Talk session. I'm your host Matt, and today we're going to focus on the LXP5 hybrid maintenance settings. Many of you in South Africa are pretty good at programming the SNA. Sales in South Africa of this particular model has been insane, and thanks to you, our brand has grown tremendously. Luxpower are promoting the LXP series, and in particular the 5 kW LXP, which competes with other top brands in the full hybrid market. The LXP5 predates the SNA by a good few years, and the maintenance tab has some significant different features. Let's take a look at the visual differences. Here we have the application settings screen for the SNA. This one you're pretty familiar with. Now let's drop in the same application settings screen for the LXP5. See the difference? The LXP is a full hybrid, so the first significant difference is the absence of the AC first settings. Let's jump into a live demonstration on what the various tabs mean, and how to do the initial setups. This is the landing page on the desktop monitoring. You will be familiar with this screen, and here on the top menu bar, all of the tabs are the same as the SNA. The display data will be familiar to you, as well as the infographics. All of these tabs have separate sub-menus, each with their own use. Make sure you have the correct station selected here, before proceeding. Let's go across to the Maintenance tab. On the left menu we have the following. Remote Set, which we will be using today. Set Record. Remote Update, and Update Record. This tab here is for Italy only. Once again, before proceeding, make sure you have the correct station selected. Let's scroll down to familiarize ourselves with the settings page, and the various sub-sections. Once we're sure it's the correct station, we can go ahead and press the Read button. This will populate the page. Now that we've clicked the Read button, let's wait for the page to be populated with data from the inverter. This normally takes a few seconds, depending on the Wi-Fi connection. It's best to wait for all the fields to be populated before proceeding. Here we have the common setting area. The time setting will be automatically updated when the dongle is online, so no need to set this. Next, we have to select the PV input mode to correctly match your PV design. You can have no PV, PV1 only, PV2 only, or all 8 kilowatts, strung in series and split over the 2 PV inputs. This entails bringing down one set of cables and splitting the positives over the 2 PV inputs. Or 2 strings separately, which means each independent string has a max of 4 kilowatts. The LXP5 has a dual input MPPT, with a max input of 4 kilowatts per string. Next, we go to the model section. The LXP5 ships standard with a CT clamp or current transducer. This clamp must be fitted regardless. To set the battery type, I suggest you do this at the power on stage as shown earlier. Or, you can click on this drop-down arrow and select from a predetermined list of lithium battery manufacturers. Remember, when you press set, the inverter will restart. Make sure you use the correct BMS cable since not all BMS protocol are the same. Failing to set up the battery correctly will result in no power output until resolved. Neutral detect is used to determine elevated voltage between neutral and earth on the AC input. It does not matter if it is left disabled, but it is useful to have. The Restart Inverter button is used to force a restart after certain updates or settings have been made. Selecting this will restart the inverter and will shut off output temporarily, so be sure you're prepared for this. The CT sample ratio is set at 1 in 1000, as a standard for the clamp issued. You can shorten or lengthen the cable, by crimping a new RJ45 plug, which is supplied. The Total Load Compensation button is for 3-phase installations where you need to compensate for unbalanced loads. Let's continue down to the application setting. The LXP5 is a true hybrid, and can blend 3 sources of power simultaneously. Let's look at the application settings section, and learn how to master this section. The Power Backup Enable function allows for uninterrupted power output when switching from on-grid to off-grid mode. Perfect for South Africa. The Seamless EPS switch enables near seamless switching, with a target switch time of 10 milliseconds. Toggling this function will switch between 10 and 20 milliseconds. The microgrid function is used when you set up the LXP in an off-grid station with a generator as backup power. Enabling this will export to the AC input socket, thus preventing damage to a generator. The PV grid off function is used to enable access to off-grid mode when only solar is available, without battery storage. I prefer to leave this disabled, unless specifically required. The grid sellback function should only be enabled and your installation has been registered with the relative local authority, and is approved for export to grid. Have a look at the wiring diagram in the user manual. It shows where the ideal location should be of the CT clamp. The LXP has the ability to send excess PV to the non-essential side of the installation without exporting to grid. This only happens when the grid is on. In an off-grid situation, export will stop, and the power supply will be directed exclusively to the EPS output. If you've optimized your site by discharging the battery at night, you should note, when the grid is on, the LXP will discharge battery to both the essential and non-essential side of your DB, but not export to grid. If you enable the grid sellback function, the grid sellback power percentage will be the balance of available solar power after battery charging and load consumption has been satisfied. As an example, if you set it to 100%, then 100% of only the excess power will be exported to grid. Fast Zero Export. This function works in conjunction with the grid sellback feature. When enabled, it will rapidly shut off export to grid as soon as the grid fails. The normal standby function allows you to put the inverter in standby mode. You will notice the message, "Waiting on order," appear on the screen. In this mode, there is no power output, and the inverter is standing by, waiting for setting instruction. The Set System Type button allows us to assign a role to each machine in our system design. In a single machine setup, you select one phase master. In a multiple machine single phase setup, you assign the roles of one phase master, and then subordinate to each slave inverter. In a three-phase multi-machine setup, you will assign the role of three-phase master, and each of the slaves will be assigned the role of subordinate. Be sure to check the user manual for the dip switch settings and parallel cable layout. The battery shared button is used when we have a parallel system, where the battery bank is shared via a common DC bus. I strongly suggest you use this feature, since it allows all the inverters access to the full battery bank. When using this feature, you will only need to have one battery COM cable between the master battery and master inverter. The slaves or subordinate inverters will get their battery data from the master. The Set Composed Phase buttons allow you to set the phase allocation in an off-grid situation, in a three-phase system. Typically the inverters will get this data when connected to the grid, but in an off-grid situation you will need to assign the phases. If your three-phase system is grid connected, the inverters will auto-assign their phase according to the grid phase they're connected to. In this case, there is no need to set the phase. The Max AC Input Power setting is a very useful feature on the maintenance page. It allows you, the installer, to set the max power value of the feed breaker you have connected to your AC feed into the inverter. Example: if you've used a 32 amp breaker and your nominal grid voltage is 240 volts, then your max continuous allowed power will be 7,680 watts. If you set this value to 7680, then the inverter will never exceed this value while supplying load and charging the battery bank from grid. The inverter will always prioritize load power first, and derate the battery charge power so that the combined power equals this set value. The CT Direction Reverse button is a feature which was added a while back. This allows the installer to reverse the reading direction of the CT, if it was installed with the flow direction arrow in the wrong direction. Pretty handy to have if the CT is in a tight spot. The CT power offset parameter allows the installer to offset any inadvertent leak current. The CT clamp's accuracy may vary from time to time, so this setting allows you to offset the minor leak. As an example, if you notice a 50 watt leak to grid with the export disabled, you will set this value to -50. In the Grid Connect section, we set up the parameters for when the inverter will connect or disconnect from the grid. The LXP5 has the ability to monitor the grid connection voltage and frequency. Should either of these be outside of the set parameters, the LXP will disconnect from the grid, and only reconnect when the parameters meets the requirement. First, we have the connect time in seconds. This timer countdown is for exporting power to grid when the solar feed is ready. This will only be allowed when the set grid parameters are within range. Check with your municipality what the delay should be before connecting to grid for export. The reconnect time is also in seconds, and relates to the time the LXP will reconnect to the grid when going from off-grid to on-grid. A typical example of this is after a power outage or load shedding. This countdown will only start when the grid voltage and frequency are stable within the preset parameter. Grid volt connect high is the upper limit of the set voltage parameter you prefer from the grid feed. If the grid exceeds this voltage, the inverter will go to off-grid mode and only reconnect when it stabilizes below this value. Grid volt connect low is the lower limit of the set voltage parameter you prefer from the grid feed. If the grid drops below this voltage, the inverter will go to off-grid mode and only reconnect when it stabilizes above this value. Grid frequency connect high is the upper limit of the set frequency parameter you prefer from the grid feed. If the grid feed exceeds this frequency, the inverter will go to off-grid mode and only reconnect when it stabilizes below this value. Grid frequency connect low is the lower limit of the set frequency parameter you prefer from the grid feed. If the grid feed drops below this frequency, the inverter will go to off-grid mode and only reconnect when it stabilizes above this value. The last value you as an installer can set in this section is the active power command percentage. Here you can select a value between 0 and 100%, which is the set value you want the inverter to perform. As an example, setting it to 90% will limit the output of the inverter to 90% of its capacity at all times. And finally, we get to the charge and discharge section. Once you understand the logic of our charge and discharge function, it will give you confidence in setting your station to meet your client's needs. The LXP clock runs from midnight to midnight, or at least from midnight to 23:59. You will notice the charge setting times areas have 3 separate time slots. This gives you the flexibility to set variable times to suit your needs. The most important thing to remember is, any gaps in the time slots allows the battery to discharge, as long as the EOD criteria are met. So let's get to it. The charge setting page start with the system charge in percentage. The LXP5 has a system charge limitation of 80 amps. Remember, a strong selling point of the LXP5 is the IP65 rating and fanless design. A drawback to no fan cooling is a limitation on the charge current. The system charge setting is in percentage, and relates to the combined solar and grid charge. The charge last feature allows the installer to specify load or charging priority. By enabling this function, the PV priority will be load, export, battery charge. This section here allows you to set the equalization voltage, period and time and charge current limit for maintaining lead-acid batteries. You can also use this function if you opt to use lithium batteries with a BMS protocol not covered by Luxpower. In the AC charge settings section, you can enable or disable the AC charge. Set the charge rate as a percentage of the 80 amp max charge current, and set the end of charge SOC. In the AC charge time slots, you set the start and end time. Remember we mentioned the clock runs for 24 hours from midnight to midnight. You cannot set times to run from one day into the next, using time slot 1 only. If you want to keep charge from 6 p.m. on day 1, through to 6 a.m. the next day, you will use charge time 1 and time 2 slots. Just as in this example. Also remember that any gaps in time will allow the inverter to discharge the battery if the on-grid EOD setting allows. And if the grid power is on, the battery will discharge to the non-essential side as well, and recharge from solar only if there is sufficient PV. The charge priority section refers specifically to solar charging. By enabling this function here, you command your LXP5 to use first available solar power to charge the battery. Here you can see, this site used battery power during the night. At this point, his load exceeded the battery capacity, and extra power was pulled from grid. As soon as solar became available, the battery was charged first, and the loads were carried by grid. From here on, grid dependency decreased, until battery charging stopped. Once these two criteria are fully met, then export will be considered, if enabled. You can also set the charge power rate and end SOC percentage in these two areas. The charge time slots are the same as AC charge, which allows flexibility. The reason we have 3 different time slots here is because some clients have different charge tariffs from their grid supply companies. Using these times allows them to avoid the high tariff times during the day, but only when solar is available. Down the bottom here, we have the bulk and float charge voltage for when you set up a lead-acid battery or lithium with no BMS protocol. You will use this if you've selected lead-acid in your battery selection in the application settings section. Our final section in this setting training is the discharge setting. System discharge power relates to the battery discharge power, presented here in percentage. The LXP5 has a maximum battery discharge power of 4 kW continuous, and 5 kW continuous on solar and battery. It's also important to bear in mind, since we do not have fan cooling, the LXP will gradually derate the output power if the internal temperature of the LXP rises above threshold. The on-grid SOC cutoff relates to the battery SOC percentage you want to preserve, while the grid is on. The off-grid cutoff SOC relates to the SOC percentage prescribed by the battery manufacturer for low voltage cutoff, to preserve the battery. If you selected lithium battery with BMS protocol in the application section, the LXP will use this flag to stop discharging the battery in off-grid mode. The forced discharge area is used to force discharge the battery in high grid tariff times. Once again, you have 3 separate time zones to suit your requirements. Here in the lead-acid battery setting, you do the exact same as above for the on and off-grid cutoff, the only difference being these settings are in DC volts. You can also set the on-grid discharge derate voltage, as seen on the right. When discharging the lead-acid battery in on-grid mode, the output power will gradually taper off, until it reaches this set point. This function can be cancelled if not required. The start discharge power import value default is 100 watts. This setting takes into consideration that there may or may be a CT sampling error. So, if the detected load is below 100 watts, but in fact there is no load, the battery might start discharging. This discharge could leak to export. So to combat this, we apply the logic as follows. If the load is higher than 100 watts, discharge is allowed. If the load is less than 50 watts, then discharge is disallowed. The discharge current limit setting allows you to preset the discharge current in DC amps when setting up in lead-acid mode. The last 2 sub-menus are Reset All to Factory Default and Dongle Set. By selecting All to Default, you will reset all the populated fields above to factory settings. You will then need to apply new settings in each field as required. The dongle set section allows you to check which server the dongle is reporting to. Depending on the serial number, you will be able to relocate the dongle to another server. Earlier dongles do not have this feature. Click the Read button first, and wait for it to populate. Then select the server from the drop-down list. Then click Set to relocate to your chosen server. Moving the dongle reporting from one server to another takes about 5 minutes to take full effect. And that brings us to the end of this training session. Thank you so much for taking the time to sit through this tutorial. If you have any queries, contact your regional distributor, or reach out to us at Luxpower head office. Don't forget to like and subscribe. You can view some of our other training videos on various topics on our official YouTube channel. I'm Matt. Doing this tech talk for Luxpower was a pleasure. Thank you, and goodbye.